Hey guys, welcome back to a new video. Alright, so I'm sorry, last video was kinda weird and it's a little bit too long, and a lot of you guys, well, a couple of you guys just really want me to concise everything a little bit. And yeah, this video is exactly like that. I'm not gonna go into the details. If you want to know the intuition behind stuff, just watch other videos. This is just like a revision or crash course of one-dimensional motion. So anyways, we start with something called speed. So speed, what is speed? Speed is just how much distance you covered or the space you covered over a amount of time. So that's speed, alright? Now, what about, so speed is a scalar quantity, and if we want to know a vector quantity, again, if you guys want to know more about vectors, you should watch videos on vectors. I'm not going to go too in depth on this right now. So vectors, we want to know vectors, then we have to do velocity. So velocity is equals to the displacement, which is the shortest path of the object that is displaced from the original position. So yeah, so this is the displacement s with an arrow over time, and then we can graph this in a time graph like that. Um, and the reason it is from the it's from a line from the origin. It's because of this. Well, we can rearrange v equals to s over t to that, and we get uh, s equals to vt, which is a form of y equals mx. That's why it's from the origin. A line crosses from the origin. And we know that m equals v, so therefore v equals s over t. And m also equals to, from math class, you already know that y2 minus y1 over x2 minus x1. Therefore, v equals sf minus s initial over time final minus time initial. So that is the main thing you guys want to know first up. The second thing, also, you can also make a velocity time graph. So velocity time graph like this, and it is also another arrow from you know uh, the origin. And why is that? It's because when you take the gradient of the velocity time graph, you will get acceleration. Acceleration is essentially just the change in velocity over the change in time. So that's acceleration. Or more accurately, it will be like that. These are the same thing, by the way. So TF minus TI is the same thing. So this one will be more commonly used in A-level physics, if you guys want to know. Now, if we rewrite this equation, A equals to VF minus VI over TF minus TI, you will get something like this. Oh wait, not TF over TI. You will get something like this. Alright, so if you get A equals to VF minus VI over T, if you rearrange it, for VF, right, you would get something like this. VI plus AT. So that's one equation that is very useful if you don't have the displacement. If you don't have the displacement, then you can find V final using this equation right here. If you want to graph this, then you have to do something like that. Oh, sorry. I'm just going to do something like that. So what it means is essentially something from VI, go to VF with a time, and then that's V. It accelerates from the initial velocity, so like that. So I'm just going to draw that really quick. Yep, so like that. So that's a graph of this equation right here. Anyways, so what you have right now is a triangle and a rectangle. And you know what? To find the distance or the displacement, by the way, if the distance is in a straight line, I mean, displacement is in a straight line, then the displacement is equal to the distance in kinematics. So yeah. Um. Anyway, so if you find the area of this under the curve or under the graph, then you will get something like this. So, alright, I'm going to show you. So, VI times T equals VIT. So, S displacement equals to VIT plus the triangle right there, the triangle. So the triangle is half base times height. So base is just T times height is VF. Actually, times height is just VF minus VI, VF minus VI. Over T, because multiplied by T actually. So we can rewrite that. Wait, like that. Okay. So we can rewrite this as equals to VI over T plus 1/2 AT squared. So that's another useful equation if you don't have the final velocity. If you don't have the final velocity, you use this equation right here. So, now, one more equation you guys have to know is, well, three more actually, is now that you have, now that you have displacement equals to VI initial times T plus 1/2 AT squared, you would want to find the VF squared. Yeah, V final squared. Why? Because what if you don't have T? So, alright. Okay, so let's try to find an equation where you don't have to put in the variable T. So the variable T, alright. So let's square this, the original equation. So we have the original equation AT right here, right? If we square this, then it would mean that VI squared plus A squared T squared. Alright? Alright, VF squared. Cool. So, what's it called? So if we squared that, then we will get 2 A squared plus, yeah, A squared plus 2 VF and then AT. Yeah, binomial theorem. If we square that, binomial expansion, and then we're just gonna get that, right? So yeah. So VF squared equals to VI squared plus A squared T squared plus 2VF AT. Now we can rewrite that as this equation right here, which is going to be equals to VI plus 2A VO T plus 1/2 AT squared. So we know that 1/2 AT squared is equal to the distance, displacement. Therefore, we can rub this out and plug in D instead. Alright, so displacement instead. And because it's 2A at the front, you would get VF squared VI squared plus 2AS. That's one other useful equation right there. This is another useful equation. Now, the second last equation you want to do is something like this. So, velocity, there's another equation for velocity as well. So, velocity is also equals to velocity final plus velocity initial. And note, this is only true when the acceleration is constant, alright? So the average velocity would be over 2, sorry. So yeah. So therefore, if we have an equation like that, Vt, because V equals this displacement over time, right? If we have this equation right here, we can then substitute that, alright, into this equation right here. So this equation right here equals to displacement equals to Vfs plus Vi over 2 times T, okay? And most commonly it will be written as this. It will be written as this times T. So that's another useful equation in kinematics. And I'm gonna make a new video in sometime in the future doing practice questions on these kinematic equations, or otherwise known as Suvat equations. But yeah, so that's one other equation. The other equation you want to know is displacement equals to Vf plus minus 1/2 at squared. So that's another equation you want to know. So yep, that is it for the kinematics and stuff. If you guys want more about the graphs, the acceleration versus time graph, velocity versus time graph, and position versus time graph, then please note that I will do them in the future.